Welcome my friends, don't forget to hit the subscriber button, you really help me by doing that. Okay my friends, so in this video what we're gonna do is gonna teach you how to, I'm not gonna teach you every single example, but I'm gonna give you one example of how, and then you from this one you can solve other kinds, similar kinds that involve powers like this as follows. You can see here the power is it has a power that is not an integer. So for this kind of integrals, what you have to do is, of course, you're gonna have to use trig substitution. And the pattern, for example, as you can see here, this pattern is u squared plus a squared. So I'm gonna use something related to trig. But the first step, my friends, to do on this kind of thing is to get rid of this power like that fractional power. So the way you do it for this indefinite integral is as follows. I know that 1/2, so I'm gonna pull out a 3 basically, and then inside I'm gonna leave x squared plus 4, and then on the outside I'm gonna put 3 dx. Now this looks like the other integrals that I've been solving, so we're gonna use that same technique. Remember, when you have these radicals, concentrate on the radical. Okay, so what does a is equal to 4? That means that x is equal to a tangent theta, which is equal to 2 tangent theta. And from this implies that if you do the calculation, you're gonna get that x squared plus 4 is equal to 2 secant square theta. And then of course, 2 secant theta. And then dx, of course, is gonna be equal to 2 secant square theta, d theta. Now that we have x in terms of theta, we're gonna change back to theta, and we're gonna change to theta here. So the integral becomes, okay, so what is 1 times dx? Dx is this one here. 1 times dx is the same thing as dx, equal to 2 secant square theta d theta. And then the radical, of course, is equal to 2 secant square cubed. So that's gonna be equal to a secant cube theta. And then of course this cancels here, so we're left with so 2 over a, that's gonna be equal to 1 over 4, and I'm gonna pull it out. Okay, so now the secant square cancel, and I'm left with secant on the bottom, so that's gonna be equal to 1 over secant theta d theta. Okay, I'm gonna get rid of this. Okay, so now that integral becomes, so what's 1 over secant theta? That's just equal to 1 over 4 times cos theta d theta. 1 over secant is cos theta. Okay, so now this is a basic integration. So this becomes 1 over 4 sine, antiderivative cos is sine, so sine theta plus c. Okay, so now that we have sine theta, okay, so if I want to change back to sine theta, I need to relate theta and x. Okay, so now I'm gonna use a triangle, a right triangle. Okay, we said that x was equal to 2 tangent theta. And remember, this I can solve for x over 2 equal to tangent theta. And in the, remember, from SOHCAHTOA, tangent is equal to opposite over adjacent. So that if this is theta here, that will be opposite over adjacent. So what's opposite is x, and what's adjacent, 2. What that tells me, if you do the Pythagorean theorem, that tells me that this here is equal to x squared plus 4. Then you take the radical. So now that I have this, I need to change sine theta back to x's. So how do I do that? Well, that would be 1/4. I'm gonna leave this here, bracket, plus c. Okay, so now from the triangle I can see sine theta. Sine theta, remember what it is? Opposite over hypotenuse. So sine theta is opposite, which is x over hypotenuse. Hypotenuse is the radical, so that would be x squared plus 4. And that should give me the final answer. And remember, the original integral, which was this one, is equal to here, this one. Is equal to that antiderivative. Alright my friends, I hope you liked my video. I know these integrals are a little harder than basic integration, but once you know the pattern, once you know remember the radical pattern, this integral become a little easier to do. Nothing, like I said, nothing is easy, but it becomes easier in a sense, because you don't have to worry about having radicals. The radical makes the big deal in this integral. Everything has a challenge, I'm telling you. For me, this is challenging, but like I said, when you're motivated, motivate yourself, and you'll see that you like to do this type of thing, and keep going. Okay my friends, don't forget to subscribe. Let me know what you think. Thank you.